Okay, so here we have a simple random sample of 500 high school seniors gained an average of X bar is equal 42. So we have the average score, the sample average. So which is this one, X bar is equal 42. And we have the distribution of the population is normal distribution, and the standard deviation sigma is 23. So we need to calculate the margin of error to obtain a 95% confidence interval. So here we have 1 minus alpha is equal 95%. So that's mean this is 0.95. So this is our confidence level. And we need to calculate the margin of error. So that's mean we need to calculate M, which is equal Z star times sigma over square root of n. So this is the formula for the margin of error calculation. So where Z star is the Z score corresponding to this alpha value. So since 1 minus alpha is 0.95, alpha will be 0.05. That's means Z alpha over 2 is the 0.025, and which you already know it is 1.96. Okay, so Z star is Z alpha over 2. So we have Z star is 1.96. So we'll plug in this value in here. So it will be then 1.96 times the sigma is 23. So this value is 1.96. This one is 23. And we also have a square root of n, and n is 500. This is the sample size. So that's mean we'll have a square root of 500 in the denominator. Okay, so if you simplify this one, you will get the margin of error, and which is 4.508. So this is the margin of error. Do you have any question? Okay, so let's move to the next one. So here it is given that a simple random of high school seniors gained an average score of X bar. And the question is, how does decreasing the sample size change the margin of error? So if we decrease the sample size, then what will happen to the margin of error? We know that M is equal Z star times sigma over square root of n. So the n is in the denominator. N is the sample size. So that's mean if this one is fixed and this one is also fixed, then if we increase n, then the margin of error will decrease. And if we decrease n, the margin of error will increase, right? Because n is in the denominator, the sample size. So that's mean if we increase the sample size, then the margin of error will decrease. And if we decrease the sample size, then the margin of error will increase. So here, decreasing the sample size increase the margin of error, provided the confidence level, that's mean the alpha value and corresponding Z star is fixed, and the population standard deviation, that's mean sigma, they remain same. And if you decrease the sample size, the margin of error will increase. So that's mean the correct answer will be this one, the first one. Okay, the next problem is we have n is equals to the sample size is 25, and we have the standard deviation. So here we have sample size 25. The standard deviation is the standard deviation is 5, and the mean is X bar is 16. So we have X bar 16, sigma is 5, n is equals to 25. And it has a normal distribution with a standard deviation sigma is 5. And we obtained a confidence interval to estimate the mean lunch bill for all diners at the restaurant, and which action will not reduce the margin of error. So now we need to determine which of the following actions will not reduce the margin of error. So we know that the margin of error is equal Z star over square root of n, right? So that's mean the margin of error will depend on this one, this value, and the sample size. So increasing the sample size. So if we increase the sample size, that's mean we'll have actually reduced margin of error. So that's mean increasing sample size will reduce the margin of error and increase the confidence level. So if we increase the confidence level, then actually we will have a smaller z star. If we increase the if we increase the confidence level. And so if we increase the confidence level, then the margin of error will also change. So that's mean, and what will happen if we do sampling from a different random sample of n equals to 25? So that's mean if we fix the sample size and if we take a different sample, so what will happen? It will actually change the value of x. So that's mean we'll have actually different value of x for different sampling, right? So that's mean it will change the value of x, but it will not affect the value of m. So that's mean the sampling from a different random sample of n equals to 25 diners will not reduce the margin of error. So this one should be the correct answer. Okay, the next problem is, suppose a 95% confidence interval is given by, so we are given a 95% confidence interval. So here the confidence level on minus alpha is 95%, and we have this is the confidence interval. We need to find the margin of error. So let's calculate the width of the interval. It will be then 20 minus 15, which is 5, and the margin of error is the half of the width of the confidence interval. Let's say this is our confidence interval. So this is the lower limit, this is our upper limit. Then, and this is our mu. So then the margin of error will be actually this part or this part. So that's been half of the width of the confidence interval. So then m will be 5/2, and which is 2.5. So that's mean the margin of error is 2.5. Okay, the next problem is the records of the 100 postal employees at a postal station in a large city show the average time these employees have worked for the postal service is X bar, and the average time they work is 9 years. So that's mean X bar is 9 years. And we have the sigma is 5, which is the population standard deviation. And but we do not know how the 100 records were obtained. So we do not know how they obtained the sample, right? How did they do the sampling? So one assumption for constructing the confidence interval is it should be SRS. So that's means simple random sampling. But here we do not know how did they collect the sample. So that's means the interval based on this information we will construct will not be trustworthy. So that's means the correct answer will be not trustworthy because we do not know how did they do the sampling. Okay, the next problem is, suppose we want a 90% confidence interval for the average amount of time spent per week on homework by the students in a large introductory statistics course at a major university. The interval is to have a margin of error 3. So they want to have a margin of fixed margin of error, which is 3. So that's mean we need to have m equals to 3. The amount of time spent has a normal distribution, and we know that the distribution is normal distribution. So this is on one of the assumption of confidence interval or margin, calculating margin of error. So sigma is equal 40, which is the population standard deviation. So we have to find the number of observations, or we need to determine the sample size. So what should be the sample size in this case to have the margin of error 3? Okay, so we need to find the value of n. And here the confidence level is 1 minus alpha, which is 90%, So that's means 0.9. So alpha will be then 0.1. So z star is equal, z alpha over 2 will be then 1.645. Yeah, 1.645. Okay, so we know that m is equal z star times sigma over square root of n. So after solving this equation for n, we will have actually z star times sigma square over m square. So now we need to find the value of n. So if you plug in z star is equals to 1.645, so this value is 1.645, and this one is sigma is 40, and the value of m, we do not want to have margin of error more than 3, so it will be 3. Then you will get the sample size is 482. And you need to, in this case, if you have a fraction for n, you will always round it up. Do you have any question? Okay, so let's move to the next one. The scores of a certain population on the Wechsler Intelligence Scale for Children, WISC, are thought to be normally distributed with mean mu and standard deviation sigma is equal 10. So we have the population standard deviation is 10 and x bar is 104.32. And the confidence level is 95%. So alpha is equal 0.05. So z star will be then, okay, z star will be then 1.96 because z star is z alpha over 2, and when alpha is 0.05, we have z star is 1.96. Okay, so now we need to construct the confidence interval. A mean of 25 scores, so that's mean the sample size is 25. So we know that the confidence interval is x bar plus minus z star times sigma over square root of n. Okay, x bar is 104.32. So this is the value of x bar. Plus minus, we need to plug in the value of z star, sigma, and n. Then you will have this part is 3.92. And this one is 104.32. And we have also plus minus. So the answer will be then this one. 104.32 plus minus 3.92. Okay, the next problem is we have the confidence level, which is 95%, and we also have the sigma value is 0.01. Sigma value is 0.01 and alpha is 0.05 because 1 minus alpha is 95%. So 1 minus 0.95 is 0.05. Okay, and we have the margin of error is m is 0.0001. So this is our margin of error. So now we need to find the sample size. So n will be then square times sigma over m square. So plug in the value of z star, and in this case alpha is 0.05. So z star will be, let me write down the z star 1.96. Okay, so do you have any question? Okay, so I can. But so we have z star is 1.96 and m is 0.001. So then we need to plug in this value 1.96 times sigma 0.01 and 0.0001 square. Then you will get, this will be 38416. So that's with this is the sample size which is required to obtain this margin of error. So the answer will be then this one, 38416. Okay, so let's move to the next one. So here, suppose you measure the lifetimes of a random sample of 100 tires rather than 64 tires. Which statement is true? So that's means you actually decrease the sample size. So previously the sample size was 100. Now the sample size is 64. So what will happen to the confidence margin of error for a fixed confidence interval? So the margin of error, we have actually m is equals to, so n is decreased. So if we decrease n, m will goes up, right? It will increase. So that's why the margin of okay. Oh, sorry. Here we increase the sample size. So we considered 100 instead of 64. So that's mean n increased, right? Yeah. So we increase the sample size. So the margin of error will decrease. So that's mean the margin of error for 99% confidence interval would decrease. So this is the correct answer because we increase the sample size. Okay, so now this is about hypothesis testing. So we have that, we have, so let me write down the information from here, from this question. So we need to test the mean score for this year's college seniors in Philippines who are interested in pursuing graduate management education will be less than this one. So that's when we want to test this. So we want to test whether the mean score is less than 563 or not. And she has a random sample of 250 college seniors. So that's mean here sample size is 250 and sigma is 118. And we have the, actually we need to just write down the hypothesis. So that's mean we need to write down the null hypothesis and the alternative. So we want to test whether mu is less than 563. So that's mean the alternative is mu less than 563. So null will be that mu is equal 563. So this is the null hypothesis and this is our alternative hypothesis. Okay, so now we'll perform the hypothesis test for the previous questions. So here we have x bar is 555. So and n is 250. And what was the hypothesized value? Hypothesis value was 563, I guess. So okay, let me check the hypothesized value. Yes, it was 563 and sigma was 118. So we have from the previous question, we have mu zero, the hypothesis value is 563 and sigma is 180. Okay, so let me check it again. Yeah, this is 118 and this is, oh, this is 563. Yeah, this is 563. So now we need to find the p-value in this case for this hypothesis test. So our test was lower tail test because our alternative was mu less than 563 and this is the hypothesis value. So now we need to find the probability p-value, which is probability of x bar less than 563. So you can convert this one to z-score and then use the z-table, or you can use this applet, p-value of a test of significance applet. So you can use this one, and that will be easier if you know how to use this one. Okay, so let me show you how to use this applet. So can everyone see the applet? Or let me share this with. Okay, so here we have mu, which is 563. So plug in 563 here. So this is the hypothesized value. This is your mu. Okay, so now sigma is 118. So here it should be 118, the sigma value. And we have x bar. X bar is right here, which is 250. Oh, sorry, x bar is 555. 555, which is the x bar sample mean. And n is 250. So this one will be then 250. Okay, and our test was lower tail test, right? So it should be mu less than this one. Mu less than this one. This is 563, not 560. Okay. So then you will click on the update and it will give you the p-value. So here you can see the p-value is 0.1419. So yeah, in this case, you even do not need to calculate the test statistic. You do not need to look at the z-table. You can just plug in the values here, and if you click on the update, you will get the p-value. And for 3 different tests. So either you can have right tail and both tail and lower tail. So for any tail of the test, you can find the p-value. Yeah, this is really nice. Okay, so our p-value is 0.1419. Okay, so let's go back to the slide. Yeah, so we found the p-value is 0.1419. So this is the p-value. Okay, so now here we have also, we need to perform a hypothesis test where the null hypothesis is this one. Sorry, the null hypothesis is this one, and the alternative is mu not equal to 0. So this is two-tailed test actually. And we are given that the data from 18 workers, so that's mean n is equals to 18, and we have the sample mean is 17, and we have the hypothesized value mu 0 is 0, right? And we have sigma is equals to 60. Yeah, the sigma is equal 60 here, the standard deviation. Okay, so this is two-tailed test. So you can use the same applet. So you need to plug in 0 for mu because we have 0 here, right? And this is not equal, so that's when this is two-tailed test. So you need to select this one. And sigma is 60. It will come from here. And n is 18, the sample size. And the x bar is 17, this one. So you need to plug in this, and you will get the p-value is 0.2293. So in this case, the p-value is 0.2293. Yeah, so what is the sampling distribution of x bar when mu is 0? Okay, so now first you need to find the sampling distribution. So to find the sampling distribution, actually we need to calculate the, to find the sampling distribution, we need to calculate the standard deviation. So, and we know that the distribution of x bar is normal distribution with mean mu, and sigma is sigma over a square root of n. So mu, well, we already know this is 0, and this one will be then 60 over a square root of 18 because the sample size is 18 and the standard deviation is 60, and you will get this, it will be 14.1421. so that's mean x bar is normal distribution with mean 0 and standard deviation 14.1421. Okay, so next problem is, this is also about hypothesis test, and we have published reports of research work are terms. They often report just a test statistic and p-value. For example, the conclusion of a test study describing the executive's LDL cholesterol might be stated as, so this is our test statistic, which is negative 1.01, and the p-value is 0.2758. Find the values of the one sample z statistic needed to complete the conclusion. So here we have the hypothesis where mu is greater than 0. So this is upper tail test. And we are given x bar is 0.3, sigma is 1. So we need to calculate the test statistic. This is actually x bar minus mu 0 sigma over square root of n. So here mu 0 is equal 0. So plug in all the numbers here. So x bar is 0.3 minus mu 0 is 0 and sigma is 1. So 1 over square root of n, and n is the samples, n is the sample size, right? So that's mean the sample size is 10. So it will be 10. So if you simplify this one, then you will get 0.9487. So that's mean the test statistic is 0.9487. Okay, now this is also similar kind of problem. So we have x bar, and we need to find the test statistic or z score. So here we have, for the second column, x bar is equals to 1.02. So here the x bar is this one, and all the other informations are same. So you will plug in all the numbers here. So this is 1.02, and we have mu 0 from the previous one is 0, and we also have the sigma, which was 1, I think, and we had also n, the which was 10. Yeah, so you'll plug in those numbers and you will get the test statistic is 3.2255. Okay, so now we have, for the same problem, we have different. So so here x bar is 17, and so this is also similar type of problem. So x bar is 17, sigma is 60, and we have mu 0 is equal 0. So we need to calculate the x bar minus mu 0 sigma over square root of n, and n is the sample size, which is 80. So now you need to plug in all the numbers here, and you will get the test statistic, and which will be 1.2021. Okay. So let's go over this problem. So a statistics teacher taught a large introductory statistics class with 500 students having enrolled over many years. And the mean score over all those students on the first midterm was mu is 78. So we have mu is equal 78. We have sigma is 10. And the sample size n is 500. 1 year, the teacher taught a much smaller class of only 25 students. No, sample size is, in 1 year, it was 25. So the teacher wanted to know if teaching a smaller class was more effective and students performed better. We can consider a small class as an SRS of the students who took the large class over the years. So that's mean we'll consider this one as a sample. So the average midterm score is x bar equals to, so n is equals to then 25. X bar is equal 83. So we have all the informations, and this is so our first we need to write the hypothesis. So the hypothesis will be we want to see whether the mean score is or average midterm grade is for the smaller class is better or not, right? So that's mean we want to see whether mu is greater than 78 or not. So this is our alternative. And null will be mu is equal 78. So that's mean the correct answer is this one. Okay, the next problem is a marketing consultant is hired by a major restaurant chain wishing to investigate the preferences and spending patterns of lunch customers. Okay, so here the CEO of the chain hypothesizes that the average customer spend at least this amount on lunch. So that's mean this is the hypothesis value. So this is our alternative hypothesis. So that's mean we have mu is at least, so that's mean mu greater than 1350. And the alternative will be then mu is equal 1350. So this is our null hypothesis, this is our alternative hypothesis. So now at level of significance alpha, so here the alpha value is 0.05 and p-value is already calculated. So we do not need to calculate the p-value. P-value already has been calculated, which is 0.077. So now we need to compare these two value. So if p-value is less than alpha, we reject the null. So that's means the data provide sufficient evidence. And if p-value is greater than alpha, then we fail to reject null. So that's means the data doesn't provide sufficient evidence. And here the p-value is 0.07, so which is greater than 0.05. So that's means we have this one, p-value is greater than alpha. So we fail to reject the null. So that's means the data doesn't provide evidence against the null hypothesis in favor of the alternative hypothesis. So this one should be the correct answer. Okay, so the next problem is the similar problem. So we have the same problem. So the sample mean X bar is 1450, the sample size is 25, and the population standard deviation is 350. So we need to calculate the test statistic. So the test statistic will be then Z is equal X bar minus mu 0 sigma over square root of n. So here the X bar is 1450 minus mu 0 is the hypothesis value, the claim, and sigma is the standard deviation, which is $350 divided by the square root of 25. So this is the answer. Or let me check what answer options we have. Yeah, so X bar minus, yes, so X bar is this one. So that's mean the correct answer will be X bar minus mu 0 is 1350 divided by sigma over square root of n. So this is actually X bar minus 1350. So that's mean this is the correct answer. Okay, so the next problem is the time until maturity of a certain variety of hot pepper is normally distributed with mean mu and standard deviation sigma is equals to 2.4. So we have sigma is 2.4. The null hypothesis is this one and alternative is this. So this is upper tail test. So I select a simple random sample of 4 plants. So that's means the sample size n is equal 4 and the sample mean is, so yeah, these are the observations. So we have 4 observations. So now we need to calculate the sample mean, And if you calculate the sample mean, then it will be, I think, if you take the average of these four numbers, then it will be, I think, 72 maybe. Yeah, let me calculate the average of this. Yeah, so if you calculate the average of these four numbers, then it will be 76 plus 73 plus 69 plus 70 divided by 4. Yeah, it will be 72. So that's mean here we have x bar is 72. So now we need to calculate the test statistic, and we need to also calculate the p-value. So we have the sample size. So the test statistics is x bar minus mu0, and mu0 is 70 here. The mu0 is 70. Sigma over square root of n. So it will be then x bar is 72 minus mu0 is 70, and sigma is 2.4 divided by square root of 4. Okay, so now we'll calculate the test statistics, and then we'll find the value of, we have to find the p-value. So if you calculate the test statistic, it will be then 1.67. Okay, so to calculate the p-value, that's mean we have to, this is upper tail test, so we have to find x bar greater than what is the, oh sorry, we have to actually find the probability z greater than 1.67, and this probability is 0.0478. So this is 0.0478. Okay, so this is the p-value. So now we will compare this p-value with the alpha value. So the first option is I would reject H0 at level 0.1, but not at level 0.05. Okay, let me clear everything. Just write down the p-value. So p-value is equal 0.0478. So this is our p-value. If p-value is less than alpha, we reject, otherwise we fail to reject. So I would reject H0, the first one, at level 0.1. No, I would, yes, I would reject at this level because p-value is less than alpha. Even I would also reject at this alpha value, right? Because if alpha is 0.05, this is still less than alpha. So actually we should reject for the first one, we should reject the both alpha value. But they said I would reject H0 at 0.1, but not at 0.05, which is not correct. And second option is I would reject H0 at level 0.05. That's correct, but not at level 0.01. That's also correct, because this is, if we consider alpha is 0.01, then the p-value is greater than alpha. So we fail to reject. So that's mean we do not reject at this level, but we reject at 0.05. So this is the correct answer. Okay, so let me look at the next one. Suppose the time that it takes a certain large bank to approve a home loan is normally distributed, with mean, mu, and standard deviation sigma is equals to 1. So here we are given the mean is mu and sigma is 1, and we have x bar is 5.3 and mu0 is 5, which is the hypothesis value, and we have alpha is equals to 0.01, and here we have the loan is 500 applications, so the sample size is 500. So now calculate the test statistic, which is x bar minus mu0 sigma over square root of n. So now we need to plug in the value of x bar, and then mu 0. So mu 0 is 5 and x bar is 5.5. So the test statistics will be then 5.3 minus 5 and sigma over square root of n. So sigma is 1 over square root of 500. And you will get the test statistic after simplifying this one. So now you need to calculate the p-value. So let me calculate the test statistics first. 5.3 minus 5 and divided by 1 over square root of 500. So times the square root of 500. So it is 6.71. So the test statistics is 6.71. So actually this is very large test statistics. So if you calculate the probability of z greater than 6.71, it will be actually close to 0. So very close to 0. Even you can consider 0. So the p-value is 0, and you can look at the table or you can calculate it using the applet for the p-value for hypothesis test. Okay, so the probability is close to 0. So that's why this is less than alpha. So for this level of alpha, alpha equals to 0.01, the p-value is less than alpha. So we reject the null hypothesis. So that's mean H0, the null hypothesis, should be rejected. So this is the correct answer. Oh, I'm sorry, I closed also this one. We were going over this one actually. Yeah, we finished this one, I think. Yeah, we finished this. This one. Yeah, this one. Okay, the next problem is we have the here university administrator obtains a sample of the academic records of past and present scholarship athletes at the university. The administrator reports that no significant difference was found in the mean GPA grade for male and female scholarship athletes, and the p-value is 0.287. The p-value is not less than alpha. So that's mean they failed to reject the null. So that's mean they didn't find any significant difference between the mean GPA for female and female. So what does this mean? So this means that what does this p-value mean? Actually, this p-value mean, so here actually the hypothesis alternative. So the alternative was actually not equal 0 because we were looking for whether there is a difference or not. So actually that means the chance of obtaining a difference in GPA between male and female scholarship athletes are as large as the observed in the sample if there is no difference in mean GPA is 0.208. So that's mean observing the statistic, what we observed from the sample, or observing the extreme value of the statistic, and the probability is 0.287. So that's the meaning of this p-value. Yeah, so that's why this one should be the correct answer. Okay, so this is the last one. I don't think so. Okay, let me check here. Yeah, we also finished. Yes, we also entered this one. And yeah, we also entered this one. Yeah, actually, we went over all the review problems, so we are done. Oh, it didn't take that much time. I thought that it will take more than 1 hour, so that's why I started early. Yeah, but it didn't take that much time. Okay, so do you have any question about the exam or about the practice problem? Yes, sure, I can review the practice problem from the beginning. So which problem you want me to review? So which problem you wanted me to review? Okay, so what with, okay, H0 and HA. So that's mean so you want me to review the hypothesis test problem? Okay, so let me show you the problems. Okay, got it. I'm sorry. So you wanted me to review this one? Okay, great. Yeah, this problem is, so here actually the GMAT is taken by individuals interested in pursuing graduate management study. So here actually we need to determine the, oh, I'm sorry, I went to the next problem. Okay. Oh no, not this one. Yes, this one. So here actually we need to write the hypothesis statements. So that's mean we need to write the null hypothesis and we need to write the alternative hypothesis. So how do you determine null and alternative? So what we wanted to test here. So actually here we wanted to test whether the mean scores for this year's college seniors in the Philippines who are interested in pursuing graduate management education will be less than 563. So that's mean we wanted to test whether the mean score is, whether mu is less than 563. So that's mean our alternative is mu less than 563. So the null will be then, null is always equal. So it will be then mu equal 563. So that's how we actually got the hypothesis statement. So is that answer your question? Okay, thank you. So do you have any other question about exam or about the practice problem?